So we're going to be graphing absolute value equations. This first part is just a review of the parent function. Does anybody know what the absolute value function does?
Make a V.
Oh, say that louder.
Turns it positive.
Turns it positive. Everything will become positive. So if I put a -3 in here, it's going to turn into a +3. If I put a -2 in there, it'll turn into a +2. So what would the -1 be?
1.
What would the 0 be?
0.
0. What would the 1 be?
1.
1. Very good. Still positive. Everything stays positive. So 2 would be a 2 still. 3 would be a 3. The absolute value, it's the distance from 0. All right, it's used a lot when you do distance, maybe in physics and stuff. So normally distance, if it's negative, it just means that you're going backwards, but it's still a distance of 3. Does that make sense? So that's why we have the absolute value. If you were to plot these points, you would see that it would make what kind of shape? A V. Right, so absolute value function makes a V. And then we have this little domain and range review. For the domain, how far left are we going? Negative infinity. How far right? Positive infinity. No matter what your V looks like, because a V will always be a V, you are forever going to be going left and forever be going right. So this will be the domain for all absolute values. If I were to write it in set builder, X is in all the real numbers. The range is different though because we are stopping. So how far down are we going?
0. Bracket 0.
0, and it is a bracket because it's a point. And then how far up are we going? Infinity. For a set builder, you always started off with the Y, the bar, and then another Y. And then ask yourself on your graph, where are you stopping? At 0. And are we using the numbers bigger than 0 or less than 0? Bigger. And is 0 included?
Yeah.
Yes, so we need to add the little line underneath.
Strawberry. Maybe half.
All right.
Can they have some too?
Yeah.
Oh,
I guess I only had 6 of them, but I suppose no, it's okay. You can take them. All right.
We're gonna take all of her.
You can take the rest of them. It's okay.
Just passing it right here.
No, we're just gonna split a
I'll
strawberry.
be offered to. She. I know.
They were. Here you go, Faith.
All right. So we're going to be transforming these absolute value functions. So the reason why we don't need a calculator for this unit is because we are going to be graphing these by hand from now on. All right, so we're going to do it by hand.
Thank you for the strawberry.
You're welcome. All right, today in class we're going to be talking about the A, the C, and the D. The A, the C, and the D. We're going to do B tomorrow, so don't worry about the B. You don't see a value in the B spot very often. But we are going to talk about it in case you ever do see it. But you do see A, C, and D a lot. So those are the important ones. First of all, anything on the inside. Inside of your absolute values, inside your parentheses. All right, anything on the inside here is horizontal. All right, it's a horizontal shift. So this C is going to be horizontal. And the inside, you also have to think opposite. All right, so inside is horizontal. And it's always going to be opposite. All right, you just gotta remember the inside is always going to be different, and the reason why it's different is because of the negative sign right there, which is making things backwards. All right, so that's why the inside is opposite, is because of that negative sign. What's up? It'll make sense when we start doing it. Alright. So horizontally shifting is you're going left and right. Right? And remember you have to think opposite. So if you have a negative C in here, are you going left or are you going right? Right.
She said you're going left and right.
No, horizontal is left or right, and depending on whether it's negative or positive will tell you which way. So if it's negative, you're going right because it's backwards.
So the
Positive equals left.
Left. Yeah.
Wait, we can move on.
I don't know.
Directions.
I guess the way you saw it or something. I don't know. This is weird.
You going left, like, where?
right.
Where?
I'm trying to
On the
solve.
graph.
What are we trying to solve?
You're not solving anything, we're graphing.
Wait, so this is the function that would be like that we enter for the graph?
You're not entering anything because you can't use a calculator.
Okay, so what?
You're graphing these functions. This is how you graph them. You'll see. Let me fill my chart out, and then
Why
we'll do
am
the
I
examples.
graphing this function?
Because I'm telling you to.
What are we trying to solve for?
You're not solving anything, you're graphing.
It's like
My brain hurts.
Okay.
Let her finish. She'll finish. Why doesn't like this one?
A and D, they're on the outside, right? Okay, so those are going to be vertical shifts. All right, so you're going to be shifting your graph vertically if the numbers are on the outside of your bars or parentheses or something like that. And the outside stuff is normal, so don't switch the outside. The outside stays whatever it is. The inside is the only thing that you have to think opposite. All right, so the inside you think opposite. So vertically would be up and down, yes? So if it's a positive, do you think you're going to go up or down? Up. And if it's negative, which way are you going? Down.
Yeah, I understand that. But I don't understand the rest of it.
Okay, the right and left.
Oh wait, okay, never mind, I didn't say that, never mind.
Okay.
You said it's opposite. So
I didn't say that.
Would you like a Cheeto?
No, I'm good.
Because whenever you're going like, you know, if it's the opposite, it's the opposite. I don't know the purpose. I don't know
Okay,
what
so this is the
Okay.
So I know the purpose.
No, but that almost happened yesterday, eighth period.
Wait, what? Where? What?
No.
Who was who?
Then I ain't just
All right, listen up. So
Oh, the same one?
this next one, we're gonna graph, which is that's the purpose, is graphing. I want to graph this. I want to graph the absolute value of x minus 2 without a calculator.
So this would be a question all on its own. It's no extra steps. It's just
So
graph.
would you just
Graph it.
Oh, I get it. So the little point would be moved to like the -2.
So the question is graph this.
Can you graph this function? It is the absolute value.
Mhm.
Okay, so it's moving on from linear functions to absolute functions.
Correct.
Okay.
All right.
That makes sense.
Absolute. So is this one?
All right. So the 2 on the inside the bars. It's on the inside. So are we going vertical or horizontal?
Horizontal.
Horizontal. And specifically, are we going right or left?
Right.
Correct.
Hey,
Never mind, I
why
got it.
wouldn't the negative be left?
Because inside is
Flip it.
opposite.
You gotta flip it. So you'd have to.
All right, this is the math behind why the inside one is opposite. So up here, right? Do you see how the negative sign is in there?
Yeah.
So in this
Oh my goodness, I don't know my left from my right.
function, c is a positive 2 because the negative is part of the equation.
Bless you.
Where
that
did
make
you see from?
So that's the placeholder. It's like mx plus b. It's how you replace the b.
So the c tells you left or right, but the negative's already in there, so that's why you don't worry about that. So positive is right. All right, and then if it was positive, it's because you have a double negative, which you'll see this is x plus 2, not double negative. But the negative's already in there, so your c value would be negative, which is why you're going left. That's the math behind it, but it's easier just to remember inside's opposite instead of trying to figure out double negatives and stuff like that. Does that make sense?
I'll say right, not put it right.
For the math way.
I don't know my left.
That's fine.
Right.
So that's the math way behind it. All right, so here's my function.
So do you just move the dot that starts it over to 2?
Say that again.
The dot that starts.
Yeah, the dotted line is where you start. It's your parent. And then you're shifting your graph right 2. So your new function is going to be shifted 1, 2. And so that's your new function.
I'm gonna write it.
Yeah, we're going to draw it.
I like web paper.
Alright, so once again, here's your function. This is the parent. And my translation is going to the right 2. So we're going to go 1, 2.
I'm literally 2 years old.
Yeah.
Yeah, guys,
Because you're 2 years old.
Alright. So my graph was shifted to the right 2. Alright, drop down to this bottom left. What kind of transformation is the 2 going to be? It's vertical, and is it going up or down? Up. How many?
2.
Very good. It's going up 2. So your graph right here is going to go up 2. So 1, 2.
Is the X
If you need it, yeah, you can have it.
is the X-intercept ever gonna move?
Yes.
Oh no.
Oh no.
Wait, what do you? The x-intercept?
Like not the X-intercept, but where the point is.
It is moving.
No, like I'm talking about. Is it ever gonna move from the?
Is it gonna
base
start
line?
somewhere else?
Oh no, it'll always start at the origin.
Yay!
All right, top right corner. Top right corner. Am I what?
It's going to the left.
Sticks. Oh yeah, sure. I'll draw a stick.
I answered it for you though.
And this
Oh.
is why I don't like
You
you.
didn't pay attention.
Sorry, Faith. Answer it again because I didn't hear.
Okay, it's gonna go left 2.
Very good. Left 2.
When I finally get something, she doesn't want to call me.
All right, so your graph is going to go left 2, so it's going to be right there.
It's gonna be right there, more like it's gonna be left there.
You look so funny too, and you just messed up your whole personality.
All right, next stick. 24. Jasmine. How is this one being shifted? Down 2. Very good.
You're just varying.
So your graph is right here, and you are going down 2. So this is your new graph.
Did you closed off
This is from the
Good.
From what?
the human race?
Human race?
Yeah.
Not really.
All right.
This is the most attention I've paid in this class.
That's good.
Because it's the easiest thing we've done.
Exactly.
All right, if this is easy, that is good. But if you're not paying attention, you probably want to because I forgot to tell you. We are going to be doing the A, the B, the C, and the D for every single function in this class.
Never
So you
mind,
are
I'll
going
listen
to
to it.
see this every single unit. So if you know it for this
It's
unit,
gonna kill us.
you're going to know it for all the other ones.
Oh, this is like set builder and interval all
Kill
over.
us.
You're going to see it again and again.
Hate us.
With Nene on the
You were just telling me how much you liked this stuff, and it was easy,
I
and
love math class. It makes me smile, but
Okay.
I hate this.
Well, here's the gag. I can do it until you get to the asymptote because I don't understand.
that's all next semester, so don't even worry about it.
Biology. Die.
All right, focus back up here for me, please. We now need to talk about the A. We got to talk about the A now. So we did C and D. Those are going to be left and right, up and down. And if you notice, the C and D are always going to be added and subtracted, right? Okay.
Work to do.
The A and the B are being multiplied. So it's a different kind of transformation. Now remember, B we're going to talk about tomorrow, so don't worry about the B. Let's do the A. Is the A on the outside or the inside? Outside. So it's still going to be vertical. And we are going to treat it like slope. Right? It's not exactly like slope, but it's enough like it so we can treat it like slope to help us graph. All right, now I promise, just bear with me through the chart, and it will make sense. I promise it will make sense. Just bear with. It's more, once I throw all the information at you, then it makes sense. But in little pieces, it's a little bit more difficult. So
Throw all of it at
we'll throw it all at you.
She's not gonna ease us into it. She's just throwing.
It's easier if I just give it all to you and then do an example. So, all right. First of all, draw some absolute value bars about your around your A's. I forgot them.
Shame.
But shame.
And Don't do that one.
Oh, girl.
Oh.
I love
Sorry.
Imagine someone who's following this right now. They're probably like, ugh.
you have a cheeseburger.
Sorry,
Jack.
You have a cheeseburger with your parents?
Yeah.
Alright. The reason why I don't want to put absolute values around that A is because what kind of numbers are less than 0?
All the numbers.
Negative numbers. Negative numbers.
Let me have some cookie, please. My stomach hurts.
All right, negative numbers. Shh. Angie, pay attention.
Sorry.
If you have a negative A value, it is a translation all on its own. The negative sign is its own translation.
Where do you see a negative sign
Hold
after
on.
this A?
Just wait. Just wait for me to go through the table. That's why I said just wait. Just wait. If the A value is a negative, that's a translation all on its own, and that translation is going to reflect over the x-axis. And so your function will be flipped upside down. So if your A value is negative, your function will be flipped. That is a translation all on its own.
I love you.
Okay. These other two boxes, you can have either a stretch or a compression. You can't have both. You can have a stretch or a compression. Reflection can go with both of them, though. That's why the chart is kind of weird. So you can have this or this, and then if it's negative, it's going to reflect. And I promise it's going to make examples when I do, or it's going to make sense when I do some examples. So just hang in there with me. All right. If A is bigger than 1, if your absolute value, which means I don't care about the negative sign, and that's really hard for people to get past. The negative sign is its own translation. It is a reflection. So you are just looking at the number. If your number is bigger than 1, for example, 2 or 5 or -3, because I don't care about the negative, or -8, those are all going to be stretches. And you're going vertical. So those are going to be vertical stretches.
Wait, just. What is a vertical stretch?
I'm going to explain. Don't worry. Just write the chart down for right now. So, what you need to be able to get past is the negative sign. The negative sign is its own translation. It doesn't matter if it's a -3. 3 is bigger than 1, so it is a stretch. Okay? What kind of numbers are between 0 and 1? Decimals and fractions. Decimals and fractions. So if I have a decimal or a fraction,
What fraction between?
1/2, 1/3,
It's gonna be a compression.
it's going to be a compression.
So smart. It could be a vertical. It's gonna get compressed.
So you are either going to have a stretch or a compression, and if it's negative, it's also a reflection. So remember, the negative is a translation all on its own. Now let's talk about what this is going to do to your graph, because I can't do it with the patty paper. Pretend like I had some silly putty. I roll it up in a ball. Okay? And I take my silly putty and I'm going to vertically stretch it out. What?
That's a taffy.
Roll it up in a ball and I vertically stretch it out, right? Is it going to get skinnier or fatter?
Skinnier.
Skinnier, right? Because when you stretch out your silly putty, it gets skinny, right? You stretch it and it gets skinnier. So when you have a vertical stretch, your graph is going to get skinnier. All right? Take my silly putty, I roll it back up in a ball.
How would you do this with an absolute value?
You'll see. You'll see. You roll it up in a ball, and now I'm going to vertically compress it. So I'm going to squish it. What happens to your silly putty ball? It gets fat, right? So your graph is going to get fatter when you compress, but skinnier when you stretch. So let's do the first example. All right. The 2. Is that bigger than 1? Yes. So is it going to be a stretch or a compression? A stretch.
Bro, I'm a stretch. This is funny.
All right, so we are vertically going to stretch this graph. Now, because there's no C or D, I'm not shifting left or right or up or down any, so I'm still starting here at 0.
Does it matter how, like, where we
Mm-hmm. Yep.
Oh, God.
And the 2, we're going to treat it like slope. So you are going to go up 2 and over 1. up 2, and over 1. Now, because I say it's like slope, you have to know your function is a v. So going back to your vertex, you're going to go up 2, and you're going to go over the other way. That's why it's like slope. It's not, bless you, it's not exactly slope because I don't have a linear line, but it's enough like it where we can graph my absolute value. And so if you look at your v, it got skinny because you're stretching.
Now, just looking at the function itself, how would I know that was just stretching? Because it don't look nothing like the example we did.
Because the 2 is bigger than 1. So because the 2 is bigger than 1, it's a stretch.
So if it's less, you
Y'all cannot
Judge me for this. I'm not getting mad.
All right. Same thing on this one. We're starting at 0, 0. There's no shifting.
I got this.
so you
What is the slope going to be? 1 over 2. So
so
we're
you
going
go
to
down one.
not down because it's positive.
Go up 1 and over 2.
Up 1 over 2. Up 1 over 2.
So it's fatter. Yeah.
Up 1 over 2. Up 1 over 2.
Why do you call compress?
Because compressing is squishing.
Getting big.
And why can't we just call it me?
I don't know. It's not mathy enough.
Squish your
What?
I've heard you say that before. Oh my god, it's
I'm not agreeing.
Girl, oh my god.
So if you look at your graph, it has been squished, right? It's been squished. So compressions squish your graphs. All right, now this other one. Is it a stretch or a compression?
No.
No, there's no number there. So it's neither, but what kind of transformation does it have?
a reflection.
There's a negative, so it's a reflection. So we are going to reflect over the x-axis.
So you literally just reflection of queen.
Right, so it's going to be upside down. So here's my vertex. And my slope is a negative. So instead of going up, I am going to go down. So I'm going to go down 1 over 1.
Oh,
Down 1 over 1.
Oh, because it's an imaginary one.
Yeah, it's an imaginary 1. And so then your graph gets reflected and it gets flipped upside down. So the negative ones will be flipped upside down.
I don't know what, but I just remember those transitions existed. Girl,
October.
really?
Yeah.
Ooh, this is Vicky boy.
Okay,
Is it next October?
don't lose focus yet. We're not done. Don't lose focus. All right, we need to put them all together now. Put it all together.
Huh?
We're gonna
Bet. I
add
think
up
I know
all the
how.
A's, B's, C's, and D's, and the 30 seconds.
Yeah, I'm going to talk about the vertex so you can start it if you want.
What?
All right, so let me talk about the vertex real fast. When you're graphing linear functions, right, because you've graphed a lot of linear functions.
Yes.
When you graph those, you always start at the y-intercept, do your slope, right? You're going to be using the same process, except instead of a y-intercept, we have a vertex now. So this is how you're going to graph all of these functions. You're going to graph the point CD. That's like your starting point. It's your vertex or your point of inflection, wherever. You're going to plot that point, and then use your a value as slope. Okay? So that's how we're going to be doing all of these functions. All right?
Yo,
So
this is crazy.
vertex is the CD. Now, remember, the C inside is opposite. That is the big thing. Inside is opposite, outside stays the same. So, on this example here, what would your vertex be at? Very good. -3, -2, because you have to switch the sign. You have to switch that sign. Inside is opposite.
I think that came in.
Okay. Now, before I move on and graph it, I want to go back and state all the translations. Yes, you need to be able to state the translations, and you have to do it with the correct vocabulary: stretch, compression, right, left, up, down, reflect, all of those words.
Um,
Up, down,
Fine.
right.
Sounds like
Alright.
the name Miley Cyrus does. He does.
German.
So,
No, food.
hold on. Whoa. No, we're not singing that right now. Okay, so you do need to know all those words, and you need to be able to state the translations. And the reason why is because it is going to help check yourself, right? It is going to be a really good check. Let me show you why. The -2, is that on the inside or the outside?
The outside.
So is it going up or down?
Down.
All right, so we're going down 2. All right, the 3, inside or outside?
Inside.
So is it going left or right?
Yeah.
Left. Left 3, because it's
Y'all
opposite.
gotta remember that.
You eventually will, because I'll say it about 1,001 times. Inside is opposite. All right, now, the number here, the 1/2 and the negative are 2 separate translations. What is the 1/2?
Thank you.
A compression, yes.
But I mean, it's a compression. It's gonna get fat. Though. I hate that word, compression. It's just gonna-
Think
So
about
you do
hydraulic press.
compression
Just
left.
say hydraulic
That
press.
doesn't help me.
All right, and then the negative. What kind of translation is the negative?
A negative. You turn it to a positive, right?
No, it's when you go up or down.
I got the
Reflect. It's a reflect.
Oh, negative reflection over the
That's what I'm
x-axis.
saying.
Yep.
X-axis.
X-axis.
Yo, are you?
Oh my God, what we doing so much?
I'm trying to understand. They just trying to be right. Like,
All right. The negative is a reflect. It's its own separate translation. So the negative is the reflect over the x-axis. The 1/2 is the compression. The 3 is the left 3, and the 2 is the down 2. So every number, everything is going to be a different translation. So when you're going through, just hit everything. The negative is a reflect. The 1/2 is a compress. The 3 is left 3. The 2 is down 2.
I got a question.
What's up?
Let me look at this.
Okay. So you start at 0, 0. When we plot the vertex, -3, -2, we are going to go left 3 and down 2. Do you see how that point matches your translations? Left 3, down 2. Your vertex is at -3, -2.
wait a second. I have a question.
What's up?
How did we get the vertex in the first place, like at all?
These 2 numbers.
Y'all doing too dang much. Don't y'all. And she's slow. No, because it's too dang much. Now,
You have to
let
understand.
the
CD.
teacher explain it to me.
The vertex is these 2 numbers, CD. So it's always going to be these 2 numbers right here. The inside one, you have to switch the sign. So instead of it being a +3, it's going to be a -3. The outside
On
stays the
front
same.
When we did the little graph thing.
hmm
Okay.
So these 2 numbers right here will always be the vertex. Okay? All right, so this is my vertex. Now, what is my slope? -1/2. So instead, we're not going to go up because it's negative. We're going to go down. So we're going to go down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. And so it is flipped upside down because it's a reflection. It is fatter because it's a compression. And my point got moved left 3 and down 2. So your graph should match your translations, which is why you need to be able to write your translations. You also need to be able to graph. I know this seems like a lot of information. This is like 80% of what your test is over. It's easier to kind of give it all to you at once, and then you practice it.
How long have we been recording?
It's been a while.
8 minutes? I know it's been longer
No,
than 8 minutes.
28, I think.
Oh,
28.
no.
Yeah. All right, axis of symmetry. Where can you fold your graph in half? At -3. The axis of symmetry and the x value in the vertex should be the same thing. All right, the domain. What's the domain for all absolute values? All real numbers are -infinity to infinity. For the range, how far down are you going? -infinity, and how far up?
-2.
Very good. All right. If you want to try this last one on your own, I'm going to write it out here and stop recording. But if you want to try it on your own and not look up at what I'm doing, that's fine.
You should put a roast on it. Like, I'm sorry my children are so annoying.
What's up? Yes, so your vertex would be at +3, 1. And then don't forget your slope is 2, so when you plot it, up 2 over 1.